Today we are seeing dizzying technological shifts, especially after the advent of the LLM. So many of us are struggling to find out what's the right way to adapt ourselves to the technological changes. But maybe it's more important to ask what are not changing. As a human, we have been used our rules of the logic to persuade and to make a decision with a group of people. So we have been following these rules, rule of the logic, for last 2,000 years. And I found that there's exactly at the intersection of these two philosophical and the technological approach, we found that there is an academic field called Argumentation Technology. And today we have the visionary scholar in this field of research who is kind of researching into this two intersection. So his vision is kind of provoke people's thought and to kind of how to enhance their critical thinking skills with the right combination. So we have Professor Chris Reed from the University of Dundee, who's going to introduce his research and how we can accommodate his approach into the real-world application.
Hello, and thank you very much for that warm introduction, and thank you for welcoming me here to join you.
Thank you very much for your time. And
thank
you. Perhaps we can sort of start with your introduction, just a brief introduction, what you have been working on, what you have in your research interest, and why it matters these days.
Sure. Yeah. So for the past 3 decades, actually, I've been working on AI modeling with a specific focus on argumentation and human reasoning. So trying to understand the ways in which people produce well-reasoned, well-thought-through pieces of linguistic material, ultimately. So the focus is very much on the performance of argumentation and the reaching of solidly justified decisions. And there's a lot to take into account, because when people argue and they disagree, when they express their disagreement, when they come into conflict, and when they try to resolve those conflicts into agreed ways forward, there are so many things in play, right? So you have to integrate the kind of face work and the politeness and all the social interaction material, because conflict is hard for people to manage. With the need for evidence, for scrutiny, and for kind of objective reliability. And all of that then interacts with the rest of the world and the evidence that's out there and the ability to test or not test, to refine and so on. And so you have this kind of nexus of all sorts of sophisticated human behaviour that kind of comes together. So there's a lot to handle if you want to be able to model and then subsequently perhaps critique or engage with or support that human reasoning. So that's been my focus for a long time, and there has been a lot to do. So,
of course,
yeah. So first of all, I mean, one of the initial problems that we had is that although, as you alluded to in your introduction, argumentation theory as a discipline is effectively more than 2,000 years old, stretching right the way back to Aristotle and beyond. But there's not a lot of what in the modern world AI researchers would call data, right? There's not a lot of raw material. And this was a problem from very early on, because there's a lot of kind of 20th century philosophy focusing on the structure of argumentation, but most of that is conducted in the analytical tradition of kind of reflecting on what must be true, rather than going out and seeing what actually is true, and how people actually argue. And that empirical turn is really only very, very recent. And so one of the things that we had to do early on was to go look at how people argue. And that sounds kind of trivial, but one of the challenges is if you want to do that, particularly in a computational setting, then you need tools, you need infrastructure, you need to be able to bring that data together, to analyze it, to annotate it, and none of that existed, right? So we kind of had to start from zero, start to build up the tool sets, the analytical techniques, the annotation guidelines, drive all of that to the point at which we're able to start collecting the data. That took about a decade, and then indeed go out and look at the way in which people argue in different domains, because arguing is effectively ubiquitous across the human experience, right? So whether you're a lawyer in the courtroom or husband and wife at home arguing about who's going to do the dishes, the processes that we go through are very similar, right? There are commonalities across all of these different domains of argumentation. But then at the same time, there are also subtleties of huge differences between how people argue in the corporate boardroom as opposed to trying to do
the contextual difference.
Exactly. So we had to go and get a lot of data from all of these different domains and apply kind of consistent annotation techniques to be able to build up large corpora and then start to build the systems based on those data sets.
Right.
And so effectively what happened over the course of, as I say, several decades was this emergence of an ecosystem of different tools and data sets and techniques and algorithms. And then about 10 years ago, what happened was that we realized that with the advent of new AI and subsequently, not long subsequently, of large language models, that we start to have the techniques for being able to automatically recognize the structure of reasoning in natural and unconstrained text. So we also started developing algorithms for that, driven in large part by those data sets that I mentioned. So the problem is that as of today, at the beginning of 2026, the state of the art is still not able to cope with the sophistication and the nuance and the kind of mastery of human cognition that is embodied within the process of argumentation. So LLMs, at least out of the box, are really still very poor at recognizing when people are giving pieces of evidence for their conclusions, how they assemble the chains of reasoning to be able to support or disconfirm hypotheses and so on. So we're at a very interesting turning point. That as there is this kind of inexorable rise in the power and sophistication of modern AI in the form of LLMs and more latterly large reasoning models, LRMs, there is a fundamental limit, it seems, to the ability of these AI systems on their own to be able to tackle this.
Gotcha. I see.
So argument technology is now at this sort of fascinating eye of the storm. In as much as reasoning is being touted and seems indeed to be of core importance, fundamental importance to what AI is able to do, and yet even just the ability to measure the sophistication and capability of LLMs requires all of this argument technology work that we've been doing over the last few years. So it's a very exciting moment in time to be working on precisely these problems.
Precisely. So before we kind of diving into a bit more technical details, I just wonder, you briefly mentioned about your work. Just wonder how your work have been applied to the different projects, like in public sector or any other sectors. And based on that, my sort of final question is why it matters to the human these days.
So that's, I think that those two questions naturally go hand in hand. So one of the things that I've been particularly interested in is how we can take AI research into this kind of ubiquitous phenomenon of argumentation and apply it in different domains to have some kind of impact. Now, having an impact is always hard, right? You have to have a lot of track record and a lot of kind of perseverance to be able to make a difference. But we've had at least some kind of small successes, as you say, some in the public sector and some elsewhere. So I can talk to you about a couple of examples. So we've had a long relationship with the BBC in the UK, which started off in our collaboration with BBC Radio 4, and in particular the production team of a programme called The Moral Maze, which if anyone is interested in reasoning and its application to topical problems, I thoroughly recommend The Moral Maze. And the setup there is a rather combative, rather belligerent interaction between 4 kind of regular panelists and 4 witnesses who are experts on the theme of the week's show, which is drawn from recent news. And the idea is that the witnesses are cross-examined by the panelists. So it's a very nice kind of setup for exploring how people argue and how they express conflict and how they reach agreement. So we started working with them to try to understand just some of the basic mechanisms of how interactional argumentation functions, how it's put together. So we first of all transcribed and then analysed in total many of their programs. I mean, I think maybe 30 or 40 episodes. And a lot of that was preliminary work in trying to just understand what we need to be able to annotate. And as we built up the data set, we started to get fascinating insights into the ways in which the dynamics of this kind of argumentation are structured. So, for example, we were looking at the ways in which turn-taking interacts with the presentation of ideas, how questioning sets up themes that then run through the remainder of the program, and so on and so forth. And one of the things that we realized very early on was that there is just a lot of data. Right, so in 45 minutes of programming, you've got maybe 10,000 words. You've got 500 turns. So you've got a lot of kind of very complicated linguistic material all interacting. And beloved of people who work in argumentation theory are these kind of box and arrow diagrams, right? That connect up premises and conclusions, and they are certainly very useful and very informative. But when you've got like thousands of boxes and arrows, it just turns into complete spaghetti. So you need other ways of kind of presenting that information. So we started to develop a series of analytics that give you insight into that abstraction through different kind of abstraction mechanisms.
I see.
So being able to show, for example, where there are kind of conflict hotspots and how those interact with the turn taking.
I see.
That kind
so
of...
when the discussion hits up.
Exactly. And so, the lessons that we learned there, we were then able to take back to the production team and say, look, we've got these kinds of observations about what's going on. And they said, that's cool. How can we get that to our audience, right? How can we get that insight and understanding of the discussion? And it's not just about who's winning, but rather about who's presenting arguments that are well defended, who's able to dig down into a position and defend it against all comers, as opposed to capitulate, or indeed who's got the best breadth, or all these kinds of rather soft notions can now be evidence driven, data driven. And so we worked with them to produce these analytics live with the program, so that they were
kind of visualizing.
Exactly.
Nice.
And all of those analytics are, at least at the moment, still available on the Norway's website. And we got huge amounts of positive feedback from listeners who were kind of fascinated to kind of compare this sort of very detailed data-driven analysis of the discussion with what was going on in the program.
I see.
And those feedback comments then led us to perform a similar exercise with the US presidential debates in 2016, where we could pin down, rather than the kind of punditry that you get from the newspapers talking about, Trump was very evasive, or Clinton was focusing on the wrong issues, or whatever. We can pin that down in the data. And that was kind of fascinating to be able to give people that sort of insight. But it also laid a foundation for then subsequently further work with the BBC in the educational arena, where we worked with BBC School Report, as was, and they have a mission to kind of improve media literacy, and in that year, I think it was 2018, if I remember correctly, we were commissioned to produce software that would help school children identify fake news. And the idea there was to look exploit the similarity between, on the one hand, poor quality journalism, and on the other hand, poor quality reasoning, and use the same tools to be able to uncover those weaknesses that suggest that maybe some reporting is fake. And this was deployed into every secondary school in the UK. And this was a tough user group, right? This is 16 to 18-year-olds. And yet we had incredibly positive feedback. So more than 2/3 of the kids said that it really did help them to identify fake news in the wild. So this was extremely positive in a kind of educational arena. And has, I suppose, spurred us on to other areas of application. And I mean, just sort of to mention a few, we've been looking at how you can surface the dynamics of discussion to improve the quality of discussion in public deliberation, in particular in citizen assemblies. We've also been looking at, in kind of a completely different setting, the ways in which intelligence analysts, who are often using very sophisticated reasoning techniques with intense time pressures on matters that really matter, and providing tools to help them come to better decisions more efficiently. And we've also been working at the other end of the spectrum entirely with mediators, so both corporate mediators, but also just like couples mediation, where the argumentation is some of the most sophisticated that I've ever seen.
That's a little logical.
So I mean, there's still logical structure, but there's also a lot of very sophisticated linguistic and emotional manoeuvring. And so we've kind of looked at how those dynamics are put together, and learned a lot about one of their key techniques, reframing, which it turns out plays a critical role in all kinds of argumentation, not just in mediation. And so we've been extending our models to account for those kinds of dynamics and to provide tools to help actually train mediators with new scenarios. So there's a broad spectrum of kind of potential applications, as you would expect.
I get that.
And I think it speaks to the ubiquity, not just of argumentation, but to the applicability of argument technology.
I get that. Makes total sense. When I was kind of describing your BBC project, I was kind of in my I was picturing like playing a sports game highlight.
Exactly.
Like argumentation, it's up, I defend it.
But that's exactly right. And I think I find it interesting that, we've become very accustomed to that kind of data-driven analysis of sports games, right? In fact, we would kind of feel almost cheated if it were absent. We want the batting averages and everything else, right? We want to be able to have that information at our fingertips, and it's fun. It kind of empowers us. And yet, for things that matter even more, like who's going to be the president or whatever, we kind of don't have that expectation. We're just accustomed to punditry and comment, rather than data-driven kind of this is what's actually happening.
Makes total sense. And I think that perfectly answers my sort of the previous second question, which is why it matters these days. We're seeing like abundant information flowing through the everyday life, and even more important, having our own gut to decide based on the large set of information. Because your thought might be sort of flooded by those information.
That's it.
Which I think the importance of this critical thinking skills is important these days.
That's right. And I mean, I think there's been quite a lot of discussion quite recently around critical thinking skills. As people start to understand some of the challenges of modern AI, and in particular, I mean, it's hugely powerful and hugely appealing to all of us, right? I mean, we all use AI in one way or another, and yet there are voices expressing some concern, particularly in the educational space, but not only, in the over use of AI. Has this tendency to dull those skills, and that we need to kind of rethink, reframe how we're using AI. And I find this fascinating because AI is an amazing tool. I mean, modern LLMs are an amazing tool for being able to partner the kind of traditional good old-fashioned AI reasoning techniques with human performance. And there's a lot of kind of concern that AI is usurping or kind of eschewing human processing, and that just seems to me to be completely wrong-headed. We should be seeing this as an opportunity for collaboration. Right. And I'm particularly interested in. I mean, these things have various names in different domains, but human-machine teaming or collaborative working. Human agent collectives I've seen also, where AI is basically given a seat at the table, right? So in very many domains, if you're trying to come to a robust decision, you will have input from a number of different perspectives or departments or areas, and people will kind of thrash it out, offering contributions to the reasoning from their perspective. And AI can provide one or perhaps more voices at that table, offering insight, offering critique, offering pushback, offering support, basically leveling the playing field between humans and machines, to be able to adduce as many different perspectives as possible to improve the quality of the reasoning. So that kind of shift from seeing AI as either the enemy or a risk or a threat to seeing it as part of the team, as the kind of collaborative environment. I think that's going to be a really cool opportunity very soon.
I definitely agree. And actually it reminds a recent article by the Harvard Business Review. So they interviewed the boss of McKinsey and Company. So they said, McKinsey boss, they said they changed the way they recruit the candidates. Like previously, what they called it case interview. It's kind of the kind of testing the candidates' sort of structure thinking, how to come up with the right logical structure. The problem is AI is even better than the other junior candidate. So they kind of changed the way of interaction. They are freely used to AI, to use the AI and get a lot of information from the AI. But you need to sort of be critically assess what was coming from the AI. That way you can. What they're especially looking at is kind of a non-linear thinking, because AI is kind of the very good at linear kind of very straightforward thinking, whereas very kind of non-linear kind of creativity, that's not easily coming from the AI. So that seems to be one picture of how AI and human can elaborate.
I think that's a perfect example. So in encouraging the challenge or the test or the evaluation of a candidate to be not on reaching the decision, but on effectively the process by which the decision is arrived at. I think that's crucial. AI has kind of forced our hand. I think that encouraging that focus on the critiquing process, on the ability to assess and judge and integrate other perspectives, and kind of challenge against. I think that's a uniquely powerful way of encouraging these critical thinking skills.
Makes a lot of sense. And it seems to be kind of the core skills in foreseeable future, I believe.
Yeah, absolutely. Yes.
That makes total sense. Now, so you mentioned like a limitation of the vanilla, like LLM out of the box. Just wanted to elaborate a little further. So I just wonder whether you have a kind of clear evidence of where the LLM's limitation is there. Because somebody may challenge that what you're saying can be actually at last can be solved by the LLM. If you kind of challenge like that, how would you kind of
so that's, I mean, obviously this is basically, I was going to say the $64,000 question. I think it's more like $64 billion question. But this is definitely where everything that is exciting in AI, a lot of it is sitting around this question of reasoning. And of course, trying to define what constitutes reasoning has been exercising philosophers for the last 2,000 years, right? So being able to pin down precisely what we mean is not a task that I'm going to take on. But it certainly seems to be the case as though there are some kinds of activities that we would naturally and intuitively recognize as reasoning that LLMs are currently unable to emulate. And I can unpack that a little bit and give you a few examples. Let me start with an example from now about 18 months ago that got quite a lot of airtime, so people may very well be familiar with this. So you may have encountered those kind of little sort of riddles that you give kids about having to measure out a particular volume of liquid using 2 jugs of fixed sizes. So, the standard one is you've got a jug of 5 litres and a jug that holds 7 litres, measure out exactly 3 litres. And then it's like that. Okay. So that's all kind of straightforward. And obviously they're all around the internet, and therefore right the way through all the training data that these LLMs have used. And it used to be the case, as I say, about 18 months ago, that if you asked GPT-4, if you've got a 7-litre jug and you've got a 5-litre jug, how do you measure out 7 litres? Right?
Yeah.
And GPT-4 would say, well, you fill the 5-litre jug, you pour the 5-litre jug into the 7-litre jug, you pour the 5-litre again, and then you pour that in, and then you're left with 3, and you empty this one, you pour this, and it's like, that's not the right answer.
Right. Yeah.
And what was happening was that the machine was generating something that looked like an answer to that kind of question, right? Because that's how they all looked. But the look of confusion on your face speaks precisely to the fact that there is an easy answer to this question, right?
Yeah.
So the machine wasn't really providing an answer, wasn't really reasoning, it was just producing something that looked like that.
Yeah.
Now, this problem was solved, right? And you can see because of the triviality of the setting, it's actually not very difficult to solve. So that no longer happens. But the phenomenon of LLMs and LRMs producing material that looks like reasoning but isn't is still very common. Now, one thing that we do have to mention here is chain of thought, because chain of thought and its related processes has become very popular. And chain of thought is, I think, a rather different phenomenon, in that what we're seeing is that by prompting for justification, you can get a better answer. And I think that is true, and I think it's been demonstrated to be true. But the thing that people often miss is that very often the conclusion of the chain of thought is different to the answer.
Right.
Or the chain of reasoning that leads you to the conclusion is inconsistent with the answer.
Right, of course.
Or the chain of thought that leads to a conclusion is in itself inconsistent. Or any other number of ways in which we're not seeing real reasoning. So chain of thought is very often not a chain, and certainly not thought. Right. So I don't think it's a very good phrase. But as basically a prompting technique, it does improve the quality of answers. Right. But I don't think that constitutes reasoning. We've got lots of reasons why that's the case. So for real reasoning, that is to say reaching conclusions on the basis of evidence, I think that we've got several indications that something is very significantly awry. Now, the first that I can mention was delivered in a keynote at ACL 2024 by Rao Kampampati, who had, I think he had a neat idea and a smart insight. So the neat idea was rooted in GoFi, in good old-fashioned AI. So he used to work, still does work, in an area known as planning. And planning has been a part of AI since the 60s. As a way of trying to kind of challenge a particular kind of reasoning. And this is sort of action-directed reasoning. So a lot of it was done in a sort of simulated world called Block's World. And in Block's World, you have blocks of different colours, like a blue block and a green block. And you have a goal state, right? So let's say the green block is on top of the blue, and the goal is that it's the other way around. And the challenge is, what do you do in the world in order to go from the start state to the goal state? And the answer in that case is you pick the one up and then you put that one on the top, right? So it's fairly straightforward. Now, it turns out that classical planning in general is computationally very hard in the general case, and therefore planners were basically trying to explore the search space in a way that was efficient and would get you to the right answer. So this is well known. What happened in the 80s mostly was that there was a shift towards some kind of commonality. They wanted to be able to test and challenge these planning systems, so they came up with a bunch of benchmark systems, benchmark problems, and there were around 600 in this sort of standard set. And so if you come up with a new planner, you can run it against these problems and see whether it beats the current scores, right? And so Rao's kind of neat idea was I wonder how LLMs do this.
Yeah.
So he just chucked the 600.
Right.
I forget which one it was. Maybe Claude. Claude did pretty well.
Yeah.
Got about half of them right, just out of the box.
Okay.
It's like, yeah, okay, cool. So LLMs can reason, or can do planning at least. And then the insight, the smart insight was, well, hold on, these standard problems and indeed their answers are all over the internet. So they're part of the training.
Right. Okay.
So it's not really fair to
it's
test.
kind of
Right?
cheating.
It's kind of cheating.
Yeah.
So, okay, let's take those problems
Yeah.
and just tweak the lexical presentation. So we keep the structure of the problem the same.
The core of the
Exactly.
question.
And then you just, so rather than talking about coloured blocks,
Right.
you talk about, I forget, animals with particular emotions or something.
So the topic was changed, whereas the cross is
exactly.
Yeah.
So it's isomorphic problem, but just the lexical surface was different.
Right.
And in the experimentation that Rao had done through 23 and 24, performance dropped from about 300 of these 600 to, wait for it, 0.
No way. 0.
Yeah. So you've got no real reasoning whatsoever.
Yeah.
Right?
Yeah.
You've got activity that looks like credible reasoning. But if it were actually reasoning, then it doesn't make any difference whether you're talking about blocks or animals, right? The reasoning structure is identical.
Of course.
And it wasn't just a drop-off. It was
nothing.
To nothing.
Right.
And I found that absolutely fascinating.
Gotcha.
Now Rao proposes a number of ways of tackling this, and there's obviously more to the story.
Right.
But the headline there, I think, is really fascinating.
Yeah.
As a way of understanding that, this is a very serious problem. It's not the problem of LLMs not being able to reason.
Yeah.
It's the problem of LLMs not being able to reason, but looking like they can.
And then deceive the people that they can be right.
Exactly. Right. So that's the real risk that is presented by these by the current version of the technologies. So one of the things that we did inspired by the work of Kamapati was to do a similar bit of analysis on argumentation. So a different kind of reasoning, not necessarily practical reasoning, action-oriented reasoning, but epistemic. And we've used a number of different examples. So we did one set of experiments around these kind of logic puzzles, where you've got, I don't know, you've got a white house, a blue house, a red house, a green house. You've got 5 scientists. You've got Einstein owns a dog. The person with the fish lives next door to the zebra. That kind of thing. Right? And then you get a question at the end like, "What's the name of Einstein's dog?" or whatever. Right? So there is always just enough information for you to be able to solve this. What's interesting about this is that you can very precisely calibrate the challenge of these problems because you can change the number of variables in each of the different categories. So we ran a bunch of experiments, and to cut a very long story short, found again that LLMs appear to do very well, particularly when the question is in their training data. But when you give them new problems, particularly more challenging new problems, the failure is abject.
Right.
We've also had a look recently at taking real argumentation. And we were inspired to basically say, okay, so we've got all of this argumentation structure and the data sets that I mentioned. So, let's have a look at one of these and pick an argument with, say, I don't know, a single premise that supports an intermediate conclusion that supports a final conclusion. And then let's mask out that intermediate thing. So we say to the LLM, here's a premise. Here's a final conclusion, and then we pick a set of things, including the actual intermediate conclusion, and then 3 other things that are rather similar. And we ask the LLM, so what should go in the middle, right? And roughly, they perform no better than chance.
No better than okay.
Right. So it's just random.
Okay.
And so it seems with all of these different kinds of reasoning, whether it's classical planning or logical puzzles or human-style argumentation, in each case, there seems to be a fundamental limitation in what LLMs can do. And I'm not able to sit here and say, LLMs will never be able to do that, right?
Yeah.
It's just that at the
Changing.
moment, there is no evidence that the current techniques are scaling in the direction of being able
Right,
to
I
solve
see.
the problems.
Okay.
Right, so
Yeah.
maybe we'll come
Yeah.
up with something extra. Maybe the current techniques will just scale. But at the moment, there's no evidence
I
that's
get
the
that.
case.
I get that. Yeah. So that limitation is quite meaningful finding because that gives a kind of room for how to the AI and the human need to collaborate.
Exactly.
together. Yeah.
Yes. So I think that this limitation in current LLM technology represents an opportunity both for the application of LLMs and also for the connection of LLMs to other types of AI, which one would be forgiven for thinking had completely vanished. But there is a lot of valuable other AI techniques and technologies out there, which can be used in concert with LLMs to be able to deliver value. And so I think that there is an opportunity on the horizon, and indeed this has been discussed in a number of places, including by Rao Kambapati, that by combining some aspects of good old-fashioned AI and modern AI that's not statistical language analysis, there's maybe new frontiers to be opened up. And I think that reasoning is a perfect example because so much work in AI prior to 2017 had been focused on developing models of reasoning of one sort or another, whether it's how to maneuver in the world or how to conduct proofs and verifications efficiently. Regardless of where you were in the space, a lot of it was about single or distributed reasoning. And so being able to find ways to have LLMs interact with these other technologies of how you do knowledge representation, knowledge engineering, how you do inferencing of those knowledge structures, and building these kind of deep connections between LLMs and LRMs on the one hand and these other technologies on the other, I think is currently at least a wide open space.
Gotcha. I see. So it's kind of the having that sort of the model-driven, data-driven approach, at the same time having a bit of technical-based approach.
Exactly right.
Kind of call that as a kind of neuro-symbolic, which is kind of neuro is kind of based on the data, and symbolic is a kind of symbolic.
I think exactly right.
Kind of conflicting each other for decades, but I think they can sort of combine.
Yes, exactly right. So I mean, people have been talking about neurosymbolic approaches for a long time. And I think that now that sort of style, if you like, is one that could drive quite a lot of advance because we're seeing these sort of fairly significant limits on what LLMs are able to do at the moment, and at the same time, there's a lot of kind of enthusiasm from the knowledge, the symbolic AI community for offering up their tools and techniques. And bear in mind that the field of computational models of argument is much broader than just the work within NLP. So you have abstract argumentation systems, you have structured argumentation frameworks, all of which offer mechanisms for doing automated reasoning and for doing inferencing and so on. So even just within argumentation theory, there's argumentation technology. There's a lot of potential there, and then as you broaden out to areas like formal ontologies and automated reasoning and so on, then there's so much more.
I was about to actually ask my next question about that because I think you kind of pointed the limitation, but also how to combine the other components to overcome that limitation. Can you sort of elaborate a sort of tangible initial success case where you sort of combine the argumentation technology into this typical LLM or any AI system to see that sort of improvement?
So I mean, combining the LLM with any other AI techniques is always going to be challenging, and it requires a lot of kind of rather dull engineering, right? I mean, it's not all exciting academic design work. There's sometimes you just need to get down to the nitty-gritty, and I think one of the areas in which we've done that, at least to some extent, is to try and help the community of people who work on the automatic recognition of reasoning structure in text. So this is the field of argument mining. There's been a huge amount of work in argument mining because it's such a challenging task. And there have been a number of kind of community efforts around kind of shared tasks and data sets and so on. One of the things that we've tried to do is to push things forward with an open framework, because you need so many different components to be able to solve the problem at large, right? So you have to be able to take the text in, and if there's dialogical interaction, you have to unpick that. You have to be able to do appropriate segmentation, and this is argumentative discourse unit segmentation, elementary discourse unit segmentation. It's much more challenging. You then have to look for connections. You then have to type those connections, and then perhaps you have to figure out what kinds of inferences or conflicts or whatever there are there too. You have to be able to fill in implicit material, and on and on and on. And what people have often done is to say, rather than trying to solve everything, I'm going to focus on this chunk, which makes a lot of sense. But then you need all of the other things to already be done in order to apply the work of that one chunk. And so what we've done is to produce a framework called the Open Argument Mining Framework, oAMF, which aims to provide an environment in which you can effectively pipeline the different components to be able to take advantage of whichever ones you want at a given moment. So if you're not interested in segmentation, you can just pull one of the segmentation modules, apply your thing to do, I don't know, connectedness, and then use an application that produces cool pictures at the end, or whatever, right? So there's maybe almost 100 different modules in the framework, some of them developed by my research group, some from elsewhere in the community, and you can actually, with very little programming expertise, you can essentially drag and drop and build pipelines and then press the go button and chuck your data in. So this is a kind of environment in which you have some modules that are either completely or very heavily dependent on the neural LLM kind of type of processing. You've got other elements that are absolutely completely symbolic in either doing automated reasoning or visualization or other kinds of processing. And then you've got some that are a mixture of the two.
Right.
So the idea is that, depending on your compute availability, depending on the task problems, depending on the complexity of the text, depending on what other algorithms you've got to hand, you might choose different combinations and build different pipelines, but all within a common language, a common framework that is kind of open and extensible. So I think that's maybe an example, at least in approach, to being able to merge these two strategies. And I think that applications that do this, and applications that go out to the general public, are probably not far behind as a result of that.
Right, I see. Okay. Segueing to the next question, which is kind of how you can sort of any further application of these, or what we discussed, like augmentation technology. You have been working on some sectors, but looks like there have been some unconquered territory, like the corporate decision making that we're working on.
Absolutely.
So just wonder how you vision the future direction of this technology.
Well, I mean, I think there's lots that might happen next, but I do think, and I have thought for a while, that how to put it, important decision making. That is to say, the making of decisions that have significant consequences. I think that that's an area in which argument technology has a potentially huge role to play. Because for decision making where the conclusions don't much matter, no one's going to invest the time and effort, right? So when you're arguing about who's going to do the dishes, I don't think argument technology has much of a role to play. But in terms of the high stakes kind of stuff, so the corporate boardroom is a perfect example. But also, I mentioned intelligence analysis is another example, and I'm sure that many people who might be watching this can think of applications in their own domains where you've got those higher stakes environments, and I think in any of those cases where people care about the quality of the decisions, then there may be a willingness to invest in technology-supported processes that enhance the quality of those decisions. And I think that corporate decision making is wide open for this. And one of the reasons is that I see I mean, perhaps it's because I work primarily in higher education, and therefore I see the kind of management in higher education, which is often based more on intuition and gut or agenda or
it's
whatever than it is on the raw data. And my suspicion is that those weaknesses are quite common. Now, that's not to say that intuition is not important. I think quite to the contrary. For senior decision makers, that intuition is incredibly valuable and important.
Of course.
But being able to exploit the data to either corroborate or disconfirm or just explore the space is largely, I think, currently unexploited, or at least not exploited in a principled way. And we might be able to develop tools and techniques that rapidly allow more thorough exploration of the decision space.
Yes, makes total sense.
And I think that that's probably one of the most interesting kind of near-term applications of argument technology.
That makes total sense because we have like abundance of the information, but sometimes our decision may not be basically kind of depend on that. And I think as you said, the decision may be at the end of the day maybe kind of dependent on the intuition, but having sort of the common agreement that the decision was based on this assumption from the intuition, that seems to be kind of the attractive area. And even further, like whose intuition contributed to the decision more?
Exactly.
This executive contributes.
Well, that's right. I mean, you can start to open up all kinds of very fine-grained analysis, and at least in my experience, there are times when customers want to do that. Also, times when they don't.
Of course. Human behavior.
But you're absolutely right. You know, as an organisation, you can get insight into where the decisions are coming from.
Exactly.
And I think because there are so many, gender and race and other sort of practical constraints, pressures rather, on how decisions are reached. Being able to surface the fact that someone who is less aggressive or less vocal is actually the source of the good decisions. Being able to track that. At the moment, it requires astute individuals with a lot of intuition about what's going on in these kinds of environments. Whereas if technology can support that surfacing of where the value is coming from, that I would imagine that for most organisations, that kind of information would be like gold dust.
Absolutely. I mean, the more transparency gives you room for the further improvement, and they're going to survive at the end. And for now, some customers may not like it, but if those kind of the companies are better at decision making, I think they're going to win.
Exactly.
So it's kind of the human behavior question, because that's sort of surfacing my argumentation like objectively. For some people, they may be open to it, but for some people, they may be a little uncomfortable. I mean, argumentation like this activity itself is not a comfortable part of your life. Whereas most of the AI tools these days are kind of evolving, making you convenient, like removing what you're doing. Whereas argumentation is kind of the other way of the direction. I'm kind of agreeing with that sort of direction, but it's kind of betting against the current evolution of the industry. And what do you think about that sort of part? Reluctance?
That's an interesting challenge to be able to tackle. I mean, for all of us, we have a kind of, on the one hand, an instinct about the hard work being able to pay off. But at the same time, an inbuilt laziness. Right? We want to avoid it. And we all see that in gym membership and attendance, right? The membership thing is relatively straightforward. The attendance requires a bit more commitment. But we know it's good for us. So, I do think that it is more difficult to engage in argumentation than not to. But equally, I think it's not just that people are intrinsically good at it. I think it's a defining part of what it is to be human.
Right.
Is to be able to do this, and I think that we all do it completely intuitively in any case. You know, when we make a decision to turn left rather than right to avoid the traffic jam, you know, that's a chain of reasoning that is just going on, you know, in an instant. And I think that being able to surface it and have the confidence to be able to follow through those steps and to articulate them with the right kind of support, it can become not just a powerful skill, but something that people enjoy doing, right? That they get pride from and that they're proud of and can really invest in, you know, to be able to produce good quality, well-reasoned arguments for their opinions. And as a result, see their opinions picked up and taken forward. So I think it's a little bit cultural for any organisation to, you know, inculcate this expectation that this is how decisions are made. I think it's a little bit personal about understanding that both offering well-justified opinions and indeed tackling other people's well-justified opinions is just a part of the process of good decision-making. And I think it's partly technological, right? About having the kinds of software and tools that are going to be able to interact in that complex intellectual and emotional environment. So, you know, for all of these reasons, it is challenging, but the payoff could be huge, right? You know, you don't need your decisions to be 100% better, right? If your decisions are just a few percentage points better than they could otherwise have been, then, you know, a company is going to transform its prospects. The problem is demonstrating ROI, right? Because you never have the counterfactual, or you never have the what would have happened if we hadn't made that decision. So being able to sell the ROI story in a way that customers can understand, that's tricky. But I think for those customers that can kind of see the potential, they can see that improving decision making is going to provide value. Of course. Then I think the value that's on offer is very significant indeed.
So as you pinpointed, there are some roadblocks, but looks like, listening from what you're saying, seems to be some inevitable road for humanity in general, because, you know, like all the tedious manual jobs are being replaced by machines. At the end of the day, what the core function of the human should be that sound decision making, and having the machine to assist that seems to be a viable approach.
That's right. And this, I mean, you know, this kind of sophisticated, multi-party, multi-issue decision-making in complex information spaces, this has been the mainstay of human activity since before the Enlightenment, right? I mean, you know, whether you're looking at the processes of government and parliament, whether you're looking at how religion is defined, right? I mean, think of the Council of Nicaea, which is 1,800 years ago. They defined what Christianity is, right? That defined its bounds. And then equally looking at how science functions, right? Science is basically just the application of these techniques, and has been since before Newton. Right. So, you know, it doesn't matter where you look, these high standards of well-reasoned, well-evidenced decision-making are the pinnacle. That's what we aspire to.
Absolutely. I definitely agree with you. And that's part of our company, DeepSkill, is kind of pushing forward, kind of nourishing the critical thinking skills for everybody. We're kind of pushing our very initial stage of the product, AI Tutor. And I think you're seeing some similar movement as well. So can you comment on how those sort of the industrial movement and how, your comment on that?
Sure. So, I mean, I think that innovative companies like DeepSkill are recognizing that there's this moment in time that I was talking about. So the technology is kind of catching up with the vision, and I think it's happening in support for training for decision makers. I think it's happening for in the moment decision making. I think it's happening for customer provider relations. I think it's happening, in B2B and B2C. I think in all of these situations. I also think, interestingly, that it's happening in government and government organisations as well.
Yeah.
That people are starting to realise that argumentation, this process of reasoned interaction, reasoned decision making, is kind of their bread and butter. It's what they rely upon. And so companies like DeepSkill that are able to say, we can provide you with technology to help you do that better. I think that this is going to change the landscape in all of these different domains as different flavours of argument technology are introduced into either training or solo decision making or multi-party decision making, and we're going to start to see better decisions being taken as a result. And I also predict, obviously I'm somewhat biased, this is my area, but nonetheless, I do predict that we're going to start to see a separation.
Right.
That, those government functions, those areas of the corporation that are using these technologies, that are being trained in these ways, that are developing these skills and taking them seriously, they're going to start to get an edge. And that will play out either in the marketplace or in other ways of measuring competition. That decision making really is where everything lies.
Right,
That's
right.
where the value
Absolutely.
is. And if you take that seriously, then it's gonna change things.
Yeah. I'm very glad that we are kind of having this journey together. Yeah. Thank you very much, Chris, for your insight, and it's tremendously insightful, and has been a really fascinating discussion. Yeah.
Thank you.
Thank you. All right. As I did, hopefully you found this discussion quite insightful. We talked about fundamental limitation of the LLM and how the field of argumentation technology can augment this fill in this limitation. At the same time, and more broadly, how it can sort of augment humans' function as a decision maker. So hopefully, we can kind of picture the future, the bright future together. Thank you.